So if we're looking at this question here, it's an example of a research scenario question that's also going to be assessing some basic content as well. Okay, and basically when we're looking at this question, we can see that we've already got some data right in front of us. So sometimes when VCA give you data, they expect you to draw a graph out of that. Sometimes they don't. So we'll see what the question is, but we'll just read through the scenario to begin with and maybe underline any parts of it that are quite important there. So the scenario is a road safety officer reviewed several case studies on the motor vehicle accident rate of drivers affected by alcohol consumption. The case studies provided evidence that many of the accidents were caused by a slower reaction time to changing traffic conditions. The officer commissioned a group of researchers to gather data on the effects of alcohol intake on reaction time of drivers. So this gives us some idea about the aim of the current study. Okay, so that's kind of giving us some clue about the aim of the current study then. 60 fully licensed drivers aged 22 to 69. What do we call this, guys? The group of people who participate in the study. We have a specific name for them. If anyone remembers, just put it in the chat box. The specific group of people who participate or take part in a study are called the sample. Yeah, basically the sample. Okay, 60 would be the sample size. That's how many participants are involved. But the overall 60 drivers that are taking part between the ages of 22 to 69 are the sample. So that's the sample. They volunteered to participate in the study. So when we say the word volunteered, what sampling procedure is most likely at play there? Or what sampling procedure was used to select the participants? Does anyone remember? Yeah, convenience. Excellent. So whenever they're volunteering, you're not making any attempt to randomize or give everyone an equal chance to take part. So only the ones who volunteer, first come, first serve kind of basis there. Okay, to participate in the study. For the study, they consumed a set number of standard drinks of alcohol over timed intervals. So maybe every 1 hour or every 2 hours, they drank some alcohol and had their blood alcohol concentration monitored. They then undertook a series of driver simulation tests. So driver simulation tests are like, if you want to test someone's driving ability, you don't like get them to drive on the actual road, but you get them to drive on like a kind of already set up area that's only meant for the purposes of the experiment, so that other people are not potentially harmed. So the public is not harmed by that person's driving. Okay, so driver simulation, just think of it as like a artificially set up environment in which a person can drive without harming the rest of the people that are in the public there. Okay. So yeah, they then undertook a series of driver simulation tests that measured their average reaction times to red lights when driving along a virtual highway. So again, it's an artificially set up environment. Reaction time was measured by determining, so now we're looking at how was reaction time operationalized or measured. Reaction time was measured by determining the time period, or basically how long it took between when a traffic light changed to yellow and when a driver's foot first pressed the brake. So that's looking at the reaction time, that number of seconds, number of milliseconds that it takes for you to see that the light is changing to yellow and to put your foot on the brake so the car can slow down to a stop. Okay, so that's the basic idea. All right, guys, looking at this particular scenario, we've got a bunch of data here with different BAC levels, okay, depending on how much alcohol the person has consumed, okay, with 0 being obviously none. Okay, and then the rest of them are just showing you the varying amounts of alcohol and basically the reaction time. So how long it takes in milliseconds for a person to react in terms of seeing that the light has changed to yellow and putting their foot on the brake. That's how long it takes. Okay, the second box. So can anyone tell me now in the chat box, what do we think the IV of this study could be? Remembering that the IV is the variable that we're manipulating. It's the variable that we essentially changing or varying. In other words, it's kind of like the cause. Yeah. What do we think the cause of this study could be, or the variable that's being manipulated in this study could be? Yep, alcohol consumption as measured by a person's BAC level. Okay, that's how we would operationalize that variable. So alcohol consumption as measured by a person's BAC level. So some participants in this study might have a 0.06 BAC level. Some participants might have a 0.02. Okay, so that's just to show that that's how that variable was measured. Okay, what's the DV in that case? So give me the DV and then operationalize the DV for me as well. So give me the operationalized dependent variable. Remembering, guys, that the dependent variable is basically a variable that we're able to measure for change. Okay, we're able to see what happens to it. Essentially, when we cause some change in the IV, that will cause some change in the DV. So what is the DV now? Can anyone tell me in the chat box? Or at least the simple DV. Yep. So the simple DV is reaction time. How are we measuring reaction time with reference to the actual study? Because remember, we can measure the reaction time between me calling someone's name and someone looking up. That could be someone that could be some way that we measure reaction time. But how was reaction time measured in this particular study with reference to what two events? Yeah, reaction time as measured by the time it takes when the traffic light changes to yellow and the time it takes to first press the brake. Okay, so that information is given here. It's literally already operationalized it for you. You just need to quote that bit of information there. Okay, and we know that the unit of measurement used is milliseconds, which is given there. Okay, this is important for us because in the next question, we're actually going to have to draw a graph for this. So it's important for us to know which variables were involved there. Okay, so let's move on to the next. Is there any issues, guys, with what this scenario is about? Let me know if there's anything in this scenario that doesn't make sense or any of this data that doesn't make sense, and we'll clarify that before we move on to the next question. All good? Okay, cool. Guys, when you're getting a scenario like this, just make sure you have a highlighter or you underline the important parts of that scenario. For example, when you get to a part of the scenario somewhere within the first paragraph that you think is the aim, just underline it and write aim. When you see that the sample has been described, highlight that or underline that. If you see the word volunteered, if you see the words randomly selected, underline those things because that gives you an idea of what the sample is, what the sampling procedure is. Okay, if it says the same participant went through both conditions, underline that because that gives you an idea that that's a repeated measures design. Okay, so a lot of this information gives you a clue as to what the different parts of that research methodology or the method section of this study is about. Okay, if you're ever asked, by the way, we did this as well for our research poster, but if a question ever asks you to discuss or evaluate the methodology, to evaluate the method or the methodology, what you're doing is you're talking about the concepts that come under the method section. Now, I know it's been a while since we did our research poster. Does anyone remember the 3 subheadings that come under that method section that we did in our research poster? Remember we had 3 subheadings under your method section? Does anyone remember the names of those subheadings? Yes, participants is one of them and materials is another one. What's the last one? Does anyone remember? The last one is the procedure. Okay, procedure was basically what was involved. If we're looking back at this scenario now that we have in front of us, you'll notice that we have all the information that we need to basically write up a method section on this particular scenario. We know who the participants were. We know how they were selected. Okay, we know kind of their background. We know that they all have full licenses. We don't have anyone that's on their L's or on their P's taking part in this study. Everyone is a full licensed driver, and there are ethical reasons for why that might be the case. Okay, we don't want to traumatize someone who's just been driving for the past 2 weeks, just got their L's. That's not going to be something we want to do. So that gives us information about the participants. Materials. We need different materials for this. We need a virtual driving kind of highway or a virtual driving environment on which we can allow these people to drive, because we sure as hell can't make them drive on the road. That's going to be dangerous to everyone around them, okay, in case they are to crash, particularly because they are under the influence of alcohol in this study. Procedure, you're just talking about what they did. They drank a set number of drinks, then they had their blood alcohol concentration monitored. They then undertook a series of driver simulation tests. Okay, the main thing is whenever you see the word method or methodology in a VCAR question, they always expect you to talk about these particular concepts. So don't get confused, because a lot of students look at the word methodology in a question. They're like, oh my God, what do I write about? Methodology is just the extended form of the word method. And we know what comes under the method section of a research poster or of a research experimental scenario. Okay, it's participants, materials, and procedure. And you're always going to be given that information in order to write that up. Even if you're not given that information, you can easily make that up. You know what is to be included under a participant section. You know what's to be included under materials, and you know what a procedure is. It's just a step-by-step rundown of how the study was conducted. So just remember, methodology equals to you talking about the participants, materials, and procedure. Now, if this question, let's say there was a question in here, there isn't a question in here about evaluating the methodology, but I want to cover all bases. Let's say the question asks you to evaluate the methodology. What does the word evaluate mean? Does anyone remember from all the SACs we've done where we've included the word evaluate? What has the word evaluate always meant? Or what has it always involved you doing? Yeah, looking at strengths and limitations. So if you get a question, let's say part A of this question is like evaluate the methodology of this experiment. All you're going to be doing is looking at the strengths, and so strengths are our positives, remember? And limitations. So our limitations are our negative of the way participants were selected, materials were used, and the procedure. If you feel like there's anything in there that's a bit, limiting or a bit flawed in terms of that methodology, you can then evaluate that. If they ask you to evaluate that, they're not asking you to quote everything directly from the scenario, but what they're asking you to do is to criticize or to critically evaluate the way that the participants were selected. For example, in this case, we've used convenient sampling. Can anyone tell me, if you remember, what's one issue? We know that convenient sampling is easy and it's, allows the researcher to have easy access to participants, but what's one disadvantage of convenient sampling, if you remember? Yep. You can't evaluate the study properly and you can't conclude, okay? You can't make a conclusive decision because, you can't generalize the results back to the population because the sample is not a representative one. Remember, if the sample is not representative, okay, so let me open another text box for this. If the sample is not representative, you cannot generalize results, okay? And this indicates a kind of flawed sampling procedure. Okay, people always use convenient sampling, and it's not an issue. It's not like it's against the law of research methods or something, but it just means that we can't generalize the results. Okay, you can't generalize the results because not every person in the population had an equal chance of being selected. So whenever you talk about the issue of convenient sampling, always talk about this idea. Not every had an equal, always talk about this idea that not everyone in the population had an equal chance of being selected. Some people had an unfair leg up or an unfair advantage in terms of them being able to be selected because it was a volunteer basis. Okay, some people might not have seen the advertisement for the research experiment in the first place, so they might not have been given the opportunity to join. So this is basically, I'm just showing you guys the range of ways that you can get questions for a scenario like this. Okay, when I was going through one of, I think, the past exams, just looking at the ones in the drive, I saw a question that said evaluate the methodology. And so that's why I decided to bring this up, okay, because I can see that if you were to get a question like evaluate the methodology or discuss the participant section in terms of the methodology, some of you might be confused as to how to approach that. Remember, it's not rocket science. They're not asking you to create this brand new theory. You're just using the information given to you in the scenario and breaking that down into the different components of that method there. Okay, cool. So I just wanted to kind of clear that up. All right, what we're going to do now is we're going to move on to the next question. The next question, or the first question is a graph question. So the question is, this is just the data taken from the previous slide. Okay, I've just snip tooled or screenshotted or cut that up or cropped that out. You've got the data there. And then the first question is, using the axes provided below, so pretend there are axes here, draw a graph of the results of the experiment and label the axes properly. So guys, what do we think in terms of the different graphs that we've studied about? What kind of graphs do you think would be relevant or appropriate to display this data?
A bar graph?
Yeah, a bar graph is a good way to do it. A line graph is another good way to do it. Those are the two main ways that we've learned or that we've seen or come across in psychology, so that'll be easier for us. We've also learned about percentages and pie graphs, but we're not using percentages as a unit here, we're just using milliseconds. And so it's going to be difficult for us to kind of put this onto a pie graph. So pie graphs are generally not assessed too much compared to line graphs and bar graphs. So there's two ways we can do this, just like you guys said, bar graphs and line graphs. So I'm going to show you both of the ways that we can, both of those types of graphs now. Before we do that though, I just want to go through this data with you. Okay, now we said in the previous slide when we were discussing and unpacking that scenario that the BAC level was basically representing our alcohol consumption. So I'm just going to write AC. Okay, and that the BAC level is basically thus our IV. Okay, and the reaction time is the variable we're measuring for change, measuring to see is the reaction time fast or is the reaction time slow. Obviously, a slower reaction time indicates a lower cognitive functioning there, okay? Because if it takes you longer to react, it means that there's some effect on your cognitive functioning. So anyway, the reaction time is the variable that we're measuring for change, and these units are 0.25 milliseconds, not 0.25 minutes, not 0.25 seconds, not 0.25%, 0.25 milliseconds. Okay, so that's important for us to know when we do up our y-axis. Okay, we need to label, give it that label. Anyway, I'm just going to write that it's the dV here. Okay, this is reaction time. So this is basically the yellow, looking at the yellow traffic light, how long it takes the people to see the yellow traffic light and then to put their foot on the brake. Okay, so does anyone remember from when we first started talking about graphs, and even when we did up our graph for the poster, which the IV corresponds to which axis? Is the IV consistent with, or is the IV equal to the x-axis or the y-axis? Does anyone remember? X-axis, excellent. Yeah, so the IV is always represented on the x-axis and the dV is always represented on the y-axis. So in our bar graph now, the x-axis is going to have all the different BAC levels, okay, and the y-axis is going to have our reaction times. Now, looking at the numbers that we have here, we know that our x-axis will end at 0.10, okay? It's not going to go to 0.12 because there is no data there for 0.12, okay? That makes sense. Reaction time, in terms of your scale, it's going to end at about 0.6 or maybe 0.8, but you shouldn't go further than that because, again, our highest number is 0.59. So if you ended at 0.6, it's more than enough. Okay, now, obviously, you need to have a proper scale. You can't just write these numbers verbatim on your y-axis. You've got to have a proper scale, like 0.1, 0.2, 0.3, or 0.2, 0.4, 0.6, like that. Some kind of a scale there where you can then situate these particular numbers in between. Okay, what else did I have to say? Also, when you do any kind of a graph, you need to give some kind of quick title to the graph and you need to label the axes as well. So when you write, for example, 0.02, 0.04 on the x-axis, you need to put a little label underneath that says this is the BAC level. Remembering that we always measure BAC level in percentages, like 0.06% or 0.08%. That's just assumed knowledge, okay, from the Dawson and Reed study. All right, I'm going to show you guys what the bar graph looks like. One more question before we do that. Because this is a bar graph, do you guys think that the bars between 0.00, 0.02, 0.04, are they going to, I'm going to show you two, and I want you to choose which one would be most correct. So let's say okay, that's not very straight, but it doesn't matter. Is my bar graph going to look like this, where everything is joined together? Sorry, this is really not good, but just pretend that everything is joined together.
Isn't that
Or
column
would it be
graphs?
more correct to use something like this, where the bars are nice and separate from each other? Which one do you think is most correct there? So this is graph A, this is graph B. Which one do you guys think would be more correct? Having the bars attached to each other or stacked, or having the bars separate? Yeah, correct. B is the correct option, okay? Now, the reason I bring this up is that some students, when they think of bar graph, this is particularly the case for students who don't do math subjects or who don't listen enough maybe in the research methods part of this subject. They often put the graphs joined together like this. That's wrong, okay? When you join them together, it's very hard for you to differentiate which data or which bar is for which value in the x-axis. So it's always important to make sure that in a bar graph in psychology, you always separate those variables there, unless you're looking at two of the same kind of thing. For example, if I'm looking at recency effect versus primacy effect for condition 1 participants. In that case, combining the two together is fine because anyway, these two bits of data are attached to condition 1. Okay, but in our case, each of them is a separate BAC, yeah? So if we look at this, that's separate, that's separate, that's separate. None of them are related to one another. They're all separate BAC levels. So for that reason, we would have a separate bar in the graph for each of those different BAC levels, okay? And so they've asked us to draw a graph other than bar or line graph. No, they wouldn't. The only exception to that rule would be if they asked you to draw like a serial position curve. But again, that would still be you plotting the dots for the lines and then just drawing the curve over that, like a little join the dots kind of thing. So that would still be more or less related to bar and line graphs. But they won't ever ask you to draw like a pie graph or I don't know, any of the other. We don't even cover that many graphs in psychology, to be honest. They won't really ask you to draw other graphs like scatter plots or those kinds of things. Yeah. Okay, so anyway, I'm just going to show you guys the sample answer, but I just wanted to give you an idea of what to expect. So this is my ugly graph, which I obviously did not use a ruler for. You should try to use a ruler. Look, you're not going to lose marks for not using a ruler or lose marks if your x-axis is a little bit crooked, but there are things that you can lose marks for. For example, if you don't label the x-axis and y-axis, okay? The basics of drawing a graph is you being able to label what the x and y-axis is. Otherwise, as the assessor or as the teacher, I don't know what I'm looking at, okay? I don't know what is the x-axis, what is being represented on the y-axis, okay? So it's really important to label those axes. You get marks for the labeling of the x and y-axis there. You also get marks for putting the title for the graph. The title for the graph is usually just the aim of the study. So the effect of different blood alcohol concentration on reaction time. That's enough. Okay. Or even just the effect of blood alcohol concentration on reaction time, full stop. You don't even need to mention the word different. Okay. So you get a mark for that as well. And then obviously having a correct scale, okay, on both ends. So looking at the fact that our BAC level ends at 0.10. So that's why my x-axis doesn't extend further than 0.10 or 0.10. Okay, and then looking at this idea, oops, where's my texter? Looking at this idea that the y-axis or the reaction time, the largest reaction time is 0.59. So I kind of stop my y-axis at 0.6, which basically accounts for the 0.59. Okay, and I just do a rough measurement of where each of those BAC levels correspond to. So we can see 0.00 here is corresponding to a reaction time of 0.25, which is quite quick. Okay, it takes less reaction time, or the reaction time is essentially faster there. Okay, so you can see 0.25. I've made an approximate judgment that this is 0.25 because it lies between 0.20 and 0.30. And then I've drawn it up. Obviously, not a perfect graph, but rather than showing you one from the solutions that is done on a computer, I just wanted to show you guys how one would look like when you draw it up, because obviously hand-drawn ones are always shabbier than the computer done ones. Okay, so this is how it would look like if an actual person was to draw it up. Okay, as you can see, my bars are not really equally weighted. Some of them are a little bit unhealthier than others. For example, 0.08's teetering towards becoming a bit overweight there, but as you can see, that's the basic idea. Okay, when you draw, it doesn't have to be perfect in terms of physical appearance, but as long as each BAC level has a separate bar attached to it or associated with it, that's all that really matters. And as long as you've used the correct scale and the correct X and Y axis labeling there. Is there anything about this graph that doesn't make sense or is confusing? Do you guys give me, like, on a scale of 1 to 10, with 10 being very, very confident and 0 being, oh my God, not confident at all. Like, if you were to get a question like this in the exam, like, how would you feel about approaching it? Would you be 10 out of 10 super confident, or 0, like not confident at all? I'm gonna skip that question altogether kind of thing. What would you say? Put your number in the chat box from 0 to 10. So I can just get an idea of whether we should maybe cover these a bit more in some optional sessions, maybe. 100 out of 10, that's good. 10,000, wow. We're really extending the possibilities of math here. Okay, that's good. I'm happy to know some of you would not find this too difficult then. 9.9, I like that. I like that. Good confidence level. All right, so that's good. I'm happy you guys would not feel too worried about a question like this, okay? Just because, yeah, it's not a hard question, but look, I know you guys, and I know most of the state gets very intimidated when it comes to research methods questions. I'm just trying to show you guys it doesn't have to be hard. You just have to use the data you've got and work with that, okay? Don't think that they're expecting you to do some big mathematical representation there. It's just sometimes as simple as a bar graph, okay? The other option for this though, the other way that you can do this question and still get it right is in the form of a line graph, which some of you talked about before. So I'm going to show you guys now how to do the line graph. Okay, so you go next one. Okay, it's the same question. So using the axis provided below, draw a graph of the results. Notice that they haven't specified what type of graph to do. And so multiple answers are possible for this question, as long as the graph that you draw mathematically and accurately represents the variables involved. Okay, so a line graph is definitely a possible option here too. So if I, for example, if we talk about a line graph, it's the same concept. You've got an axis. You're going to plot the BAC level on the x-axis, plot the reaction time on the y-axis. But rather than drawing graphs, you're basically drawing little dots. For example, where the 0 placeholder on the x-axis is, you go up to the position of the y-axis and see where 0.25 is and draw a dot. And then you just join the dots together and that forms a line. Okay, that's what a line graph is. And this is what it's going to kind of look like. Okay, again, a very ugly looking graph. Maybe you guys can use a ruler. I literally could not find my ruler. So that's probably my fault. But again, like I said, it doesn't have to be super dead straight. They're not going to deduct marks for that, but it has to show the right values there. Okay, so if we go over this graph now, you can see that we've got, oh, sorry, this should be X, not Y. Okay, that's the x-axis and that's the y-axis. Okay, so that's basically the two axes there. We've labeled the axes again, so BAC level percentage, reaction time milliseconds. Okay, we've labeled it clearly. We've put a quick title there as well, just above the graph. Okay, the effect of blood alcohol concentration level on reaction time, that's it. And we've used the same kind of scale, so starting at 0.0 and then ending at 0.10. Okay, that's the basic idea. So you can see that that's our scale, and for the y-axis it's the same. We start at 0 and we end at 0.6 because our largest millisecond number there is 0.59. So that gives us enough kind of thing. As you can see, I'm a little bit off here, but it should have probably been around here. Anyway, this is what happens when you do a graph like this at like 12 a.m. Anyway, that's the basic idea. Okay, so what we do is we go 0.00. Okay, we look at that, we match it up to 0.25 milliseconds. So I just go up, and then I just put a dot there. Okay, and as you can see, I've done that for all the different values as estimated as I could be. This would be better if I used a ruler and more accurate, but as I said, I could not find my ruler. So 0.29, 0.34, 0.43, 0.59. Okay, and then all I did was I have this bunch of dots, and just like a little join the dots that you would have done when you were in primary school, you just join the dots together as straightly as you can, and that forms a line. And that's your line graph for this particular scenario or this particular data. You can see that the line graph, just similar to the bar graph, is still showing us that there is a incline, that as the BAC level goes higher and higher, so as a person drinks more alcohol and their blood alcohol concentration gets higher, you can see that the reaction time increases. Reaction time increasing might not sound bad, but it is bad, because when your reaction time is longer, it basically means you're more delayed. It basically means that it takes longer for you to react, which is not a good thing. It means that you are slower to react. It means you're going to take more time to press on that brake when you see the yellow traffic light, compared to someone who's at a 0.0 BAC level who press it straight away. Okay, because of your slow reaction time, because you're at a very high BAC level there, you will take longer to press the brake, and you might actually press the brake so late or so delayed that by the time you properly brake and the car is stopped, you're in the middle of the intersection of that road, or you're basically almost going to crash into another car because you weren't able to stop before the traffic light. Okay, so that's showing you that a higher reaction time in this case is not a good thing. It's actually a bad thing. And this is something we need to think about for the next question as well, okay, which is the content-based question. Any issues, guys, with drawing this kind of a line graph? Look, it's up to you. Usually you will get a choice. So depending on the data that you're given, you can decide whether you're more comfortable drawing it in the form of a bar graph or a line graph. Now, question is, would you get marks if you drew both? Now, this is a kind of hazy area. If you have enough time in your exam, which you probably won't to actually draw two, even if you draw both a line graph and a bar graph, you're not going to be marked for both. So whichever one you draw first, that's the one you're going to get marked for. The same thing with questions like normal content questions. If we ask you for two, let's say, behavioral effects of sleep deprivation, and you give me three, I'm only going to mark the first two and completely ignore the third one, because the third one is basically what they say is out of the bounds of that question. If we ask for two, we only mark the first two. We don't mark the first three. Okay. I know in the SAC, sometimes what some of you do is you give me three, and then, if the first one is wrong, but the next two are correct, you expect a mark for that. But even in the SACs, we didn't really give you marks for this, okay? Because this is how they mark in the exam. They only mark the first two in the order in which you write it as correct. And if you've mentioned another one that's correct, they won't mark that. They'll completely ignore that. Same thing goes for graphs. Whichever graph you draw first, that's the only graph they're going to mark. So why bother wasting your time? Just draw the one that you're the most confident with, whether that's a bar graph or whether that's a line graph, okay? That's the basic idea. I think bar graphs will be easier for the majority of you. So just stick to the one you're most comfortable with there. Okay, so now let's move on to, we just have, I think, one or two content-based questions I want to go through, and then we'll be done for today. So this was the graph question. Now we're looking at a more content-based question. So again, kind of related to research methods, but you need to link it back to the study as well. So I'll just read the question, and then I'll give you guys a bit of time to give me some ideas. It says, explain a strength and limitation. So strength obviously being a positive and a limitation being a drawback or a negative of conducting an experiment to gather evidence about the effects of alcohol on reaction time. So we want to link it back to our current study compared to accessing case studies. So here we're looking at two types of ways in which we can collect data, basically comparing an experiment, number one, with a case study, number two. And basically, how can an experiment be better and how can it be worse in terms of gathering data, okay, about the effects of alcohol on reaction time compared to a case study. Okay, so you might want to talk about a plus point or a plus or good thing about case studies for collecting data, as well as a negative. So essentially, you're talking about one positive of an experiment for collecting data on alcohol and reaction time, and then one negative. And then you're talking about one positive of case studies for collecting data on alcohol and reaction time, and then one negative. So that's what you're doing. And that's why it's worth 4 marks. You get 1 mark, 1, 2, 3, 4, 1 mark for basically talking about each. Now, if you don't link back to the actual case study or link back to the actual topic of this experiment, which is effects of alcohol and reaction time, even if you give me 4 points, you can only get a maximum of 2 marks because you haven't linked back to the scenario. So I want you guys to just think about this for a minute or two, and then just give me some points that you think would be relevant here. Okay, points that you think are related to the drawbacks and the advantages or the strengths and the limitations of experiments and case studies for this topic or this particular research area. And I'll kind of just pause the recording while you guys think about that so we don't keep that running. Yep. So when we're looking at this question, you just need to talk about a strength and a limitation of an experiment for this particular topic of effects of alcohol and reaction time. And then you need to talk about, again, a strength and a limitation of conducting a case study or finding information about alcohol and reaction time using a case study. So that's why it's worth 4 marks. By the end of your answer, you need to discuss one strength and one limitation of an experiment for investigating this topic, and then one strength and one limitation of a case study for investigating this particular topic. Okay, now that is messy, or I would say that's a messy question, because there's a lot of things that you need to take into consideration within this question, and you might not know how to structure it. Okay, like I said, sometimes Vika give you placeholders like strength. They'll write down strength and limitation for you in your answer, and then you start writing your answer underneath that. You might have seen this in some of the previous exams as well. Sometimes the template's already given to you and you just start writing your answer from there. Okay, so that's sometimes how it works. Okay, so I'm just going to show you guys a sample answer. This is not the only answer, by the way, but this is just a sample answer. So because it's worth 4 marks, you do need to give a little bit of detail there. It's not just a simple case of listing points down. Okay, so the strength could be, and look, I've put the placeholders as well. So the strength could be experiments allow researchers to establish a cause-effect relationship between blood alcohol concentrations and its effect on reaction time. So I'm linking it back to the topic by actually quoting alcohol and reaction time there, rather than just saying cause-effect relationship, full stop. And then I use a comparative word or a linking word there, and that word is whereas. Okay. Case studies make it more difficult to determine a relationship between IV and DV, because remember we said case studies are just simply looking at a person and looking at their behavior and their functioning over a period of time. Okay, but it doesn't really always give us a causal relationship. And remember that it's very hard to determine a causal relationship with a sample size of 1. And most case studies involve an in-depth investigation of an individual or a person. Okay, and that's more common than case studies on groups, okay, because it's obviously hard to do an in-depth investigation on a group of people as opposed to just one person. So that's kind of one of the limitations. Okay, when we're talking about experiments in terms of their limitations, okay, experiments are often set up or they're done in a formal and controlled environment, and this can cause participants to act in an unnatural way or unrealistic way. For example, our participants in this study, they were driving in a setup simulation on what I think it was called a virtual highway. It's not a real highway. So they might not drive naturally as though they were driving on an actual road. They might actually deliberately make more errors or deliberately be like, oh, it doesn't matter if I don't put my foot on the brake now. It's not like it's a real road after all. What's the big deal? No one's going to get hurt. So they might start thinking in that way, and that can actually cause them to respond differently. And this actually can act as a confounding variable on the results. In case studies, however, behavior can be more natural because we're not putting this person into a setup or artificial environment. We're literally just staying with them and just observing their natural behavior. Maybe we observe them as they do their, for example, drive home. Okay, so we're observing their behavior in a more natural way and not forcing them into an artificial environment. Okay, so that's the basic idea. So you can see here, the structure that I've used might be different from the structure that you've used. So what I've done is I've talked about a strength of an experiment, and I've contrasted that with a limitation of a case study. And then I've talked about, again, a limitation of an experiment and then contrasted that with an advantage of a case study. You don't have to do it this way. You can just literally talk about strength, limitation, limitation. So strength of experiment, strength of case study, limitation of experiment, limitation of case study. I don't know why I wrote it like that. That's just the way I did it, but this is not the only way to write it up. Any questions, guys, about this question? I know this is a confusing question. That's why I wanted to cover this, just to show you guys that it's just a matter of taking the information you know and setting it out in that kind of a structure or that kind of a way. Also notice in this answer, guys, that rather than just talking about the general advantages and disadvantages of experiments and case studies, or rather than just giving a general definition or description, I've made sure that I'm always trying my best to link it back to the actual question, link it back to the aim of that study, okay? Link it back to this idea of BAC level, okay, of behavior after the BAC level, okay, of the driving simulation even, because that's what the study involved in this scenario, okay? So that's what you need to also be able to do. Whatever question you get, try to make sure you're linking it back to the scenario as much as possible, okay? Remember, I said Vika will never ask you to simply describe an experiment or describe a case study. It's more about describing that with reference to the experimental scenario they've given you, or with reference to the experimental link that they've mentioned in the question there. Okay, that's the basic idea. Alrighty, so let's move on to the last question then, if no one has any major issues with this question. We'll move on to the last question. And again, I will give you some time to also work on this question as well. So I think I'll give you about maybe 2 or 3 minutes there to work on this question. So let me just reset my timer. And have I stopped the recording? No, I'll pause the recording here while you guys brainstorm some ideas. So alcohol, we need to talk about this idea that alcohol is a depressant. We need to talk about the fact that what does that mean? What does a depressant do to the nervous system? And then we need to basically link this back to our study. So the last part of your answer will link back to the study, and we'll talk about how alcohol would thus increase the reaction time. So by reducing or dulling or dampening the effect of the nervous system, how does that then lead to some kind of cognitive we would say cognitive impairment or cognitive deficit, which would then contribute to an increase in reaction time. So that's literally all the answer is asking you to do. So if I can just project that answer up. Okay, what you would say, or what you would need to say, is number 1, alcohol is a depressant. Number 2, it makes participants, it makes, oh, sorry, I'm reading the answer here. Just reading one of the answers in the chat. By making brain slowing down brain activity, this increases reaction time as it took longer for. Yep, that's a good answer. Okay, so when we're talking about this answer, the sample answer that we're looking at this idea that alcohol is a depressant. So you've got to name that. That's the first thing that you've got to do. Okay, that word depressant is actually a key word. Okay, so worth 1 mark. The second mark goes for you explaining what does that mean. For us to say that alcohol is a depressant, what does that actually mean? It means that alcohol would have slowed the central nervous system functioning of the participants, which would have reduced their brain and bodily activity. Okay, and then you need to link that back to this idea of reaction time. So you could say this would have led to an increase in reaction time because it takes longer for participants to judge or to perceive or to see the sensory message of the traffic light changing to yellow, and the motor message for their foot to press onto that brake also gets delayed as a result of that. Okay, because we know that the brain or the central nervous system is central and is basically very important and very integral to us being able to make these kinds of judgments that, oh, the traffic light is changing yellow. Oh, I've got to make the decision that I've got to put my foot on the brake and stop the car. Okay, all of that decision-making process, that judgment of sensory information is all based in the brain. The brain is a part of the central nervous system. And when alcohol is depressing or dampening or reducing the functioning of the central nervous system, obviously a quick reaction time or a fast reaction time is no longer possible. That's why it leads to an increase in reaction time, which doesn't mean that reaction time gets faster. It means that reaction time actually gets slower because it takes you more milliseconds now to react as compared to before you drank the alcohol. So that's basically how we would do it. I'm just going to finish reading some of the answers in the chat box. But in the meantime, if you guys have any, let me know if you guys have any specific issues about this question in the chat box as well. Okay, just read this one. Alcohol concentration is because alcohol is a type of depressant. Okay, so that's basically how it would go. Okay, the main thing in this answer, guys, is to notice that you need to make some reference to, if you can talk about specifically how the participants show reaction time, mentioning something about the fact that it takes them longer to press on the brake or longer to see that the traffic light has changed to yellow, that would make your answer all the more specific and all the more better. Okay, so just try to make sure that you're linking to the scenario as much as possible. Okay, but that's the basic idea. Depressant, central nervous system functioning gets reduced or slowed, thus an increase in reaction time as shown by participants in the scenario doing blah, 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 or taking longer to react or longer to press the brake or longer to see that the traffic light had changed to yellow. So it's making some indication that their reaction has been delayed and that would then lead to this kind of a functioning on the experiment or this kind of behavior in the experiment. Cool. So this is an example, guys, of a difficult question. Okay, so a difficult or challenging question that you could possibly encounter. Again, it doesn't have to be challenging. You just need to think about, underline the important parts of the question and just make sure you address each of those parts of the question there. Okay. Another thing I just want to mention before we finish up for today is this idea that when you're given a question and you're given the name of a drug in a question like alcohol, or you're given the name of, let's say, I don't know, a drug like benzodiazepines, okay? Or you're given the name of a drug like ecstasy or cocaine or something like that. And if it says in the scenario that this drug has caused heightened levels of arousal in a person or heightened levels of functioning, you need to be able to link the word heightened to the fact that this drug is a stimulant, okay? Sometimes names of drugs or names of particular substances or substance, things that people would engage in substance use with are included in a question because they want to hash out the keyword from you. They want you to be able to identify that ecstasy is a stimulant. They want you to be able to identify that benzodiazepines are a depressant, okay? They want you to be able to sorry, not depressant. They want you to be able to identify that alcohol is a depressant, for example. Okay, so they want you to be able to identify and hash out that keyword from you. So always be very critical when you're reading questions like this and ask yourself, should I be including the keyword in there? If you're in doubt, but you know that alcohol is a depressant, just include it anyway, because there's nothing to really lose from that. It's just one word, but it could be the difference between you getting 3 out of 3 and you getting 2 out of 3 on a question like this. Okay, so always be critical and super hyper aware when the name of a particular substance like alcohol or the name of a specific drug is included in a question there. Okay, and obviously you're not going to get names of drugs you've never heard of before or have never studied before. You'll always get some scenario that gives you a clue, okay, that that drug is a stimulant or that that drug is a depressant. Okay, so that's the basic idea. Cool. Any questions, guys, about any of the questions that we've gone through today, and also any suggestions for what we might cover in our next class? I'm just going to probably stop the recording here.